Hi there, this is Sampath Ram. In this video, I'll be showing you how you can draw the schematics in Cadance and then simulate them. For that, you need to have a Unix account, which you can create by going to Unix, SJSU, and then if you are an SJSU student, enter the details and then create the account. Now, there are three ways you could log on to your account. One is either 289 lab or 291 lab, or you can remote access. You can do remote access to those labs by using a software called TightVNC Viewer. Install it on your computer, just Google it and then you'll get the TightVNC software. Download it as per the Mac. It will works for the Macs and it works for the mobile too. The mobile application is called Remote Repair. So the address you need to connect to is eecad.engr.hjsu.edu. Just don't add any extensions, it will automatically choose the correct aspect ratio when you click here. Now log on with your credentials. It will take a couple of minutes if you are logging in for the first time. Once you have logged on, you will be landed onto the desktop screen, just like the normal Windows or the Mac, wherein you can play around with the icons, you can create shortcuts or something like that. Here we go. So in order to set up the Cadance, you need to install it by using a few commands. So if you are comfortable with Linux commands, then you would definitely love this. So let's browse and see the shortcut or the command to install the Cadance onto your user first. For that, there is one PDF called, just a small tutorial on Cadance. Just type Cadance PDF HSU. The first one would be the one which I'm referring to. I have already downloaded it. Let me just show you by opening that. And the double click is not enabled onto the users now. It will be just a single click to open it. So once you have that, right click anywhere on the desktop and then go to console. The command which is used to make a folder is mkdir space the folder name. Let's name it proj3. Now in order to go to that folder, type cd space and the folder name. Now you are in the folder. The command line is in the folder. Now let's set up the Cadance using this command cp, which is there in that PDF. cp space minus setup 45 / star space a period and then click enter. Now Cadance setup file is being installed. In order to open or check whatever is installed, type ls, so that as you are in that folder, you'll be able to see what all command has installed. So S45 is the one which you need to open in order to get to Cadance. So in order to open any particular execution file, the command is this dot / and then the file name S45. So whenever you want to log in next time, you don't need to do all this. You just need to enter that folder, which is cd space the folder name which you have given, and then dot / S45. That will take you to the Cadance. So here is the Cadance. We have the Cadance. So this is just the information about the improvements in 6.1 version. You can read that if you want. So as you are doing it for the first time, go to the file and then new, and then create a library wherein you can save all your project files onto that if you do anything further. So name the folder like E224. Attach this library which you're going to create to the previously existing library in the Cadance, which includes all the voltage sources, current sources, everything. So attach it to the existing technology library and then click OK. It will ask you which technology we want to attach it to. It's GPDK5. Select it and then click OK. Now your library is created. See, click new and then go to cell view. Now this is where you start creating the schematics. So name the cell. Let's name it inverter, as is the first one. Click open with schematic Excel, which supports larger files. You can do smaller ones too. Click OK. Now the schematics thing will be open. You can play around with all the elements. You can keep whatever you want, like the voltage sources, current sources, amplifiers. So this is where you can keep all the elements. So in order to put an element, just click on the small icon over here, which creates an instance. So click browse and then go to GPDK5. Let's add PMOS 1 volt. So and then click on symbol. There's the symbol. You can put how many ever you want and then click escape if you don't want. If you want to edit the properties of NMOS or PMOS, just right click on the element and then go to properties. You can change the width, length, etc. Now let's wire it up. This is PMOS and this would be NMOS, right? So we can directly change it over here. Right click on it, properties, and then here, instead of going to browse again, you can just change the name here to NMOS, then press enter. Yeah, that's it. There you go. So let's wire this up. So in order to wire it, the shortcut is right here, just beside the create instance symbol. Now let's power it up. Let's go to symbol and then go to analog library and then type VDD here, or else you can type VDC or VDD. Let's try with VDD. Then add another one. You can change it again by just clicking on it and then properties. Let's type V only to become ground. Yeah. So let's add the names for the wires. You can name it with this symbol. There is a small icon with letters written on it. You can write all at a time. Input with a space in between. Output VDD VSS. Let's add one by one. Input, output, VDD, and then the VSS. Now that we have this, let's put the pins, input pin and the output pin. These are the major things, right? So let's add them. Let's first keep input output. I need to keep only input or only output. That's also fine. This will also work, so doesn't matter. But let me change them. So select it, go to properties, and then choose it as input. Oops, sorry. Input. Click OK, and then this is your output. So properties, then the output. Click OK. Yeah, you're all set. The inverter is ready now, and you did not assign the value for the VDD. If you want to change the length and width of the PMOS and NMOS, just right click on them as I said before. Then you can adjust the width. So let's do this. Let's remove this and then try in a different manner. Go to instance, click, then browse, then analog library, then VDC, then the symbol. Now there you go. You can assign a value for this. What's the value? If your value is 1 volt, then click hide. Let's wire up we don't need to attach all the way to, till that point. Just need to name it the same way, the same name, and they are by default connected. It is VDD right now here. So once we name this wire as VDD and this as ground, that will be automatically connected. Just to name it VDD VSS, hide VDD, then the VSS, and also let's put a common ground. Click copy, then the ground. There you go. The inverter is set. Once you're done attaching everything, just click. Oh, we have got 4 errors. Let's save it, and then if you have some errors, you can see them here. Here's a shortcut to net ground. Okay. Now let's check save. How many errors are there? No errors. So that's it. So if you would like to use this inverter circuit onto the other things, let's create 2 more pins like VDD and VSS, so that it will be easier to allocate the voltage sources in the other circuits. Because if you allocate this VDD and VSS, we need to again allocate for everything. So keeping other pins for the VDD and VSS would be a good idea. So let's do that. Let's delete the extra wiring. Then let's add a ground here. And then name it VSS. And then the pins, these would be the input output. Yeah, so that's it. Click check save. 2 errors. Shorted to ground. Okay, what we can do is add another voltage source. And then let's keep the value as 0 to ground the noise as well. Now check save. No errors. That's it. Now let's create the cell view or the symbol for this inverter. Go to create, click cell view, then from cell view, and cell name would be inverter. Click OK. The top pins would be the VDD, the bottom pin would be VSS, and then click OK. Now you can create the symbol for this. Okay, you can free draw now. So now that we have it, click save. Now the symbol will be saved, no errors, the inverter symbol is saved. You can use this symbol whenever you want to use it next time instead of drawing everything again. Now let's launch ADEL, which will simulate as per the instructions which you give. Like you can do the transient analysis, DC analysis, AC analysis for this input by giving the input and output for this. We haven't given any input for this, so we can do it by creating a new file and then importing the inverter symbol and then assigning the input by using a VDC or the other pulse or other signals. So let's do that. Go to new and then the inverter test bench, and then Excel, click OK. Now it will be open in a new tab, no need to worry about it. So let's bring up the inverter symbol now. Browse. Now it won't be in the GBDK, it will be in the project file which you created, inverter and the symbol. Yeah, here we go. Now you have your inverter, you don't need to create everything again. Now let's assign the voltage sources and the, if you want to do DC analysis, let me show you how you can start simulating so that you can do it. So once you have the circuit ready, go to ADXL or ADEL and then choose the input and output by selecting this option. Click from schematic and then the input would be this one and the output would be this one. So input output is selected, click OK. Now choose the type of the simulation which you would like to do, transient, DC, AC or some things like that. You can choose and then click run. Make sure you don't use so much stop time, otherwise it will take a long time. So just you can optimally use 50 nanosecond as a stop time. So until that point, at every single step which you define, it will generate the response based on the input and the output. So that's it. Click it and then click run. You'll be all set. This, if you select plotting mode, based on that it will plot and give you the response. One most important thing which I would like to add is that once you're done simulating, click file, close all, and then now go to file, click course data and then choose everything, select all or else click all and then click OK. Otherwise what will happen if you don't close like that is, if you try to open the Cadance in other computer after you log off, it won't let you open the previous files because all files will be locked. So it is always good idea to click close data and then select all and then close. Now we can exit. Now you can close the terminal by command exit. Now make sure you log off, don't forget to log off, otherwise it will create problem logging into other computers. Click log out and then click log out. Okay, let me show you how you can change your desktop. Right click desktop settings, you can change the screens. Now go to the Fedora, click leave, go click log out and then click log out. That's all. I hope this video helps a lot. Thank you very much for watching. Have a good day. Bye bye.